All right. Well, insulating with natural materials is a very important thing that we need to do in regards to having healthier, of course, materials go into our homes to make them more sustainable and healthier for the people that we're building and renovating for. In addition, by selecting more natural materials, we're starting to reduce that embodied carbon, that embodied energy, that upfront carbon and upfront energy, whatever you want to call it, which is starting to grow as a more important aspect of carbon usage within the housing sector as more and more homes are getting energy efficient and achieving net zero goals. In addition to that, by having more natural materials, we're of course locally going more local with our material selections and supporting local and regional economies and farmers as well. So there's all sorts of benefits, and that's what we're going to get into today. So we're excited to be having you join us. But before we dive into it, I do want to give you all a quick reminder that GreenHome Institute is celebrating our 25-year anniversary this year, which is very exciting. And so we are doing our 25K by end of 2025 fundraiser. So you can go ahead and grab your phone and click on that QR code there or the link, which kind of got messed up here, but I'll drop it in the chat. And you can go in there and help contribute and help us reach that goal so we can keep these sessions going. All right, so again, welcome everyone to Insulating with Natural Materials 101. So glad you could join us. This session is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. Like all of our courses, this course is approved for multiple continuing education units, and this really should be three pillars in our Certified Green Home Professional designation under health materials, and the energy one seems to be missing, but that one as well. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Grab that 5-digit passive house code at the end and it will be printed on your certificate as well. And a huge thanks to our new International Code Council sponsor, Energy Smart Institute, for providing ICCCUs moving forward on our sessions. Check them out over at Energy Smart Institute and look for the ICC code within your certificate. So with that, I am excited to welcome our speaker here today, Lindsay Love. Lindsay, it's great to have you on. Welcome, and please go ahead and take it away.
All right. I am with Regenerative Building Solutions. I'm based in Driggs, Idaho, tiny little town in the Rocky Mountains. I work sort of regionally throughout the whole area. And I'm really excited to be talking to you today about insulating with natural materials. Um, there's a few, I think most of you may be architects or designers or project owners or developers. And there's a few kind of key points in working with natural materials, especially as insulation, that we need to be conscious of. But there's a lot of benefits to them that we'll go over. And there's more and more products available on the market these days that makes it a little easier and more approachable. So, as Brett Little said, my name is Lindsay Love. I call this my getting old slide. Um, I've been working in design and construction throughout the Rocky Mountain region for about 25 years. I co-founded Love Shack Architecture, which is technically based in Bozeman, but we were a regional remote firm prior to COVID. My partner, Lindsay Shack, and I lived in places we wanted to be and we didn't want to move, so we just started a remote firm that was based on implementing passive house methodologies in our conservative, high cost market and a very cold climate. The places we were working when where I still work are typically like climate zones 6 and 7. We found that we had a lot of success in cracking the passive house nut, because there was a lot of trades training available, well, not a lot, but there was some trades training available that enabled or empowered contractors to understand the principles from the same perspective that we were, and bringing a lot of value in that to our clients. But on the materials side of things, that training didn't exist. And so I eventually decided that I needed to create a consulting company to help architects and builders understand the values that these materials can bring. So now I'm operating Regenerative Building Solutions, and I primarily consult in a couple of ways. I can consult specifically about materials and kind of jump into a project at any point in time and help guide and make more healthy and carbon storing choices. I also operate as a subcontractor, and I don't travel everywhere, but I have been traveling throughout the Rocky Mountain region to actually do some installation of materials, and I can provide pretty much any service that an architect or a subcontractor would provide. On the more general holistic sustainability side of things, and with my experience being on the 2030 working group, I saw, well, and practicing owning a small firm, I saw a huge gap in the the dissemination of resources and knowledge for small firms to implement sustainable strategies, especially related to market barriers. Um, and so I've taken on an additional task of consulting for architects on how to implement sustainable or materials action plans, which hopefully can be integrated into profitability strategies. And it's really kind of like a next step of your business model or business plan. And I want to share with you about the Rocky Mountain Natural Building Conference, which is why Jean is here with us. She's the executive director of the Rocky Mountain Natural Building Conference. We're a small organization, but we host these conferences every couple of years. And this is the first time it's been in Montana this year. We'll be in Bozeman in September. And if you are interested in learning more about using natural materials or carbon storing materials, we've got an incredible lineup of keynote speakers. We've got hands-on workshops, and we'll even be showing small films. And there's opportunities for everyone to participate and present. We'll have like an open house science fair where you can showcase your projects, and we would welcome you. All right, so getting into the specifics of utilizing natural materials. Why would we bother? A lot of you here on the call probably have your own reasons, but these are some of the boxes that I see them checking. I enjoy working with natural insulations more than, say, fiberglass or foam products. They're less wasteful. They are easier on our bodies and our skin to work with. Obviously, less toxic or non-toxic. Carbon storage is way more acknowledged nowadays than it used to be 10 years ago. It's kind of a new phenomenon it's not a phenomenon, it's just I guess it's a phenomenon that we're finally acknowledging it. They're more easily repairable. As a subcontractor, I've been doing quite a few repairs, and noticing that the materials can be reused, and that the only materials that need to go to the landfill in the end are literally sometimes the masking materials. So that's a pretty not an obvious bonus, but a really great one. Being biodegradable or mineral based. They can sometimes be more locally available if you're using pretty raw materials. And they can contribute to more socially just, more transparent pipelines of materials, and more circular economies. And then the hygroscopic nature of these materials is the biggest win from a building science and a durability standpoint. The mold resistance is also a huge win that people are not really aware of. I think we have a cultural perception that when we talk about natural things, we envision that they are very susceptible to moisture and will break down easily. And that's can be the case, but it's not always the case. And when implemented with good quality design and detailing and execution in the field, they lead to more durable buildings and assemblies. And then the opportunity for some of these materials to be multifunctional, like stacking functions, permaculture principle, we can have more, what I consider more authentic and elegant assemblies that are simpler. There's fewer tradespeople involved. But ultimately, why I like using natural materials, and I became an architect because I wanted to design and build with pretty raw materials, to build shelter with them, is that nature is not a place to visit. It literally is our home. And I think that we have an innate desire. I've seen this in reactions to my clients and occupants of buildings I am involved in, that there's a reaction to the materiality upon arrival and through being in the building when we're surrounded by these materials that our ancestors were surrounded by. I don't think that's I think that this is a thing that has not been studied at all, but I think it's well, I shouldn't say that, it is a part of biophilia, and we're learning more and more about how important that is. And for those of us that do need to bring it back to building science standpoint, Joe Seabrook stated a while ago that when we're working with higher performance assemblies, we have to recognize that they have much lower drying potentials, and the newer petrochemical materials, they just do not handle water as well as older materials, which just happen to be natural. I like this slide, and I want to share a couple of things about it. I like it because we're not looking at any graphs or like statistics or numbers. We're just looking at the plant bodies and learning something from the shape of them. And a couple things that we can learn are like, what are the inherent like properties of an insulator that we can gather from the shape of their plant being. And then also the other point is the embodied carbon in that. And I think as architects, we know that best practices are like to study embodied carbon and track it and its data, but just simply the principle of like seeing a plant body and understanding a little bit of like what it takes from getting from its state in its natural habitat, it's a living being, to then implementing it within a building assembly, like how disconnected is that process, and how can we get back to a more simple process while still acknowledging our cultural need for maybe packaging or ease of scale into the industry. Today we're going to talk about a couple of categories of insulation. We often talk about in-cavity versus exterior insulation or outsolation. We're going to go over some moisture management rules of thumb, some air sealing options, some product and material options, and I'm going to stay pretty general about it. And I'll get into just a little bit some sourcing tips, cost, ease of install, and opportunities for stacking functions. All right, so in-cavity insulations are comprised of grass fibers, which can be used in bundles. They need to be packaged into bundles in order to easily incorporate them into an assembly. And straw panels are bundled with, surrounded by framing. We've got some paper wrapped insulation materials. And then we don't really see in the US these reeds being used, but it is becoming more popular. Again, like a resurgence of a traditional use of reeds in Europe. Then on the fluffy side of things, a little bit more processed, we can use wood waste, newspaper or cardboard waste as cellulose, and we can also use chopped straw. Taking that a step further and processing and packaging it into bats, we have hemp bats, cotton bats, which both of these, all of these can be sourced at big box stores or online through distribution organizations or individual companies. There's way more opportunities than there were 10 years ago. And then I'm not going to get too much into these materials that are packed with binders today, but they are really, they are valid opportunities also. They're a little more raw and a little bit less easy to implement into conventional projects. But they can be very beautiful and easy to apply plasters to. Just to give you an overview, straw and hemp are a little bit different, like their bodies are different. Hemp is kind of a woody plant. It's strange. It's not exactly like a grass or a reed like bamboo is. It's more solid, and it can be chipped into these herds. They're a little more like wood chips than straw is, which is, it's called straw because it is hollow. And so when you pack them, they have a little bit different properties, but they can be combined with lime or clay to be held in place into a wall or a roof or a floor. And they've been used traditionally for thousands of years. On the exterior side of things, we have in Europe more opportunities for bundling of long reeds. And then in the US, we have wood fiberboard insulations, and there's several different versions of it that offer different stack functions. Hemp fiber, there's a new hemp rigid fiber panel on the market, which is made in Idaho, which is really cool. And then cork, which is always going to be coming from Spain and Portugal, but it is a pretty regenerative market and is available in the US. All right, to dive into some moisture management rules of thumb, in any cavity wall, the rules of thumb vary by climate, and you must refer to your code, run a moisture management model, or work with a consultant if you are just diving into using them. But on this slide, we're talking about protection from exterior water. So the first rule is like what water coming straight down from the sky. Do you have a roof overhang? It is not a requirement, but if you don't, do you have a good quality rain screen that I also want to mention is not acting like a fire chimney? And then I always think of an exterior finish as a sacrificial layer. That the exterior finish is bearing the brunt of exposure to the elements. And then we could have a whole conversation about what means to be sacrificial layer and the amount of maintenance involved. I won't get into that, but if we have time at the end, I would love to take a minute too, because I think it's really important. Drainage and flashing are the next protection, and like not only directing water away from it, but the integration of those typically metal pieces of material, they need to be integrated in a way that is not causing problems. Like sometimes it can direct water into the building, and it can also if you have like a plaster or a render finish, it can contribute to deterioration of that finish and maintenance requirements. Where is your weather resistant barrier? Do you have a skin or a finish that actually is the weather resistant barrier? Do you need another layer? Where is it located exactly within the assembly? And then what is your shear strategy? Are you using sheathing? Is it on the exterior? Where is it? Um, so,
Um,
or yeah,
Lindsay, would you be willing to quickly go back to something you pointed out about the rain screen and fire resistance, or is that a whole, I guess maybe in a brief summary, would you be able to elaborate on that?
yeah. I don't often see rain screens that are designed with like 2 inches of gap between the structure of the building and the finish, but we just need to know that they should be kept like to half inch or less to avoid having a draw effect
Hmm.
and causing more of a problem.
Yeah. And I guess while we're on the note of fire, looking at just some of these mentioned natural systems and their flammability, like um, wool, and then they said temp bat insulation versus fiberglass. I don't know if that didn't stand out to me on what that meant, but maybe you know. So
Hemp bats versus
I
fiberglass?
think it was a typo. It probably was hemp. Yeah.
Yeah. Yeah. So yeah, most of the insulation materials that are on the market have a fire retardant chemically built into them. And I believe that's the case with both fiberglass bats as well as hemp bats. Um, with cellulose and I think with
Hmm.
these other products, it's not the same kind of fire retardant that we see in foams because foams are so
Hmm.
flammable. We can use something a lot less toxic in fiberglass or hemp or cellulose. It's like a borate chemical that's not terribly toxic to us.
Right. Thank you.
Yeah, thank you. Okay, protection from water on interior. So here we're kind of talking about like catastrophic failures within walls. And this is something that we don't often think about in cavity walls. But I think that the natural building movement has taken this on because that community has a desire, a propensity for improving systems, and B, because there's a lot of criticism about natural materials. So in this case, you can see a sill or what we call a toe up, and it is filled with an insulative material between the structural components on either side that are supporting a straw bale. And the material in the center is there's a number of things that you could use, cellulose or chopped straw, or this happens to be vermiculite, which would not mold as easily if there were a catastrophic water failure inside of the wall. Um, and when I say catastrophic water failures, I don't want to give you the sense that these types of walls invite that, but I want to be aware that when we integrate plumbing fixtures or plumbing pipes into exterior walls, or we have equipment on rooftops that can send water, if they fail, they could send water into a wall. Like that's kind of the thing we're talking about. Um, and then also vapor openness for drying. And I'm going to talk about condensation next, which kind of relates to that. So in terms of protection from water on the interior, especially in a cold climate and a high performance wall or roof, we need to be aware of the risk for condensation in the cold time of the year. Um, and there are resources and rules of thumb that you can follow. And running a WUFI or water management model is very beneficial. And then keeping your insulation, your exterior insulation, especially choosing a vapor permeable product, is another safeguard against it. Or I should say, you may have condensation, but at least it allows it to dry out. So it's a safeguard against mold or rot. Um, So the rule of thumb, and this is coming from Green Building Advisor, and the numbers on the right, the image on the right with the climate zone and the minimum R value. This is specific to foam, but the same principle applies. It's the R value that they're talking about here. So as you can see in zone 7 and 8, or in all of them, as you go up from a 2x4 cavity size wall, which has an associated R value depending on whatever insulation you're using, as you go up to a thicker interior cavity, 2x4 to 2x6, the R value of the exterior insulation is increasing to protect, to like keep the sheathing warm or protect it from becoming a condensation plane. So this has a couple of effects. For one thing, if you're designing like a 30 or 40 R value double stud wall, and then you also want to incorporate additional exterior insulation to like completely eliminate any thermal bridges or something, or whether it's a double stud wall or whatever, like a high insulation wall then requires more insulation on the outside to keep it warm. That at some point becomes counterproductive and not cost effective. You end up adding extra structure and thereby increasing your thermal bridging and or embodied carbon. And if you're using foam especially, it's going to have a really dramatic impact. I should say, let me clarify, XPS, the blue board and the pink board are what I'm talking about when I am talking about like an extremely high impact. EPS and mineral wool and polyiso, those are foams that have much, much smaller embodied carbon and less environmental harm. I just want to acknowledge though that they do increase, they're not vapor open, and they increase your risk for moisture problems. And they are petrochemical products with all sorts of other problems associated with them. This is a graph that I created to just highlight the different embodied carbon and the extreme potential of natural insulations. And this is kind of a redundant slide, just we need to ensure that the drying capacity of the wall exceeds the wetting potential. So using a vapor open insulation is superior. This graph is specific to rock wool versus XPS or blue board or foam board, pink board. And it's not indicating that rock wool is bad. What it is indicating that is that a vapor open insulation is demonstrably better over time for the durability of the wall or roof. Okay, we're going to get into some air sealing options. And these are the different strategies that we'll go over. Flash and bat, tapes and membranes, tapes and sheathing, and plaster and tapes. And oftentimes you can combine these for a holistic system. Okay, so flash and bat. I'm sharing this because if you are an architect or a builder or a project owner that is most familiar with just straight up full assemblies full of spray foam, like that's where many of us are in the industry. And I want to include this one because I understand that it's a very hard leap for many to say, well, okay, I can't, if I'm gonna not use spray foam, I have to learn all these extra skills to be able to implement some natural materials. And really what I want to promote is that you could simply reduce your use of petrochemical products, which is great. That's a great place to be and to start. Just one moment. I'm gonna mute myself for a second. sorry, I have to mute myself again for a second. More easily enables us to safely use natural materials, specifically like the fluffy or dense packed products that we'll talk about more later. We're significantly reducing our use of petro products when we use tapes and membranes. They are durable in terms of like they don't become brittle. They have very, very good adhesion developed. We're reducing flammables in assemblies and obviously reducing embodied carbon. They do require more of a learning curve to use, but I don't want to say I don't want to characterize it as like it's more of a learning curve. It's just a different strategy. And I know that oftentimes folks are opposed to integrating the learning processes because it's harder to run a business if you're learning all the time. But I just want to indicate that like once you've done it, it's very easy. The hardest part is really integrating and thinking through the sequencing so that you can have the sequencing of framing specifically so that you can have a continuous air barrier around the entire perimeter of the building. The integrations at the wall and floor connections and roof and wall connections are the most tricky. And sometimes integrating special structural components like posts and beams. All right, tapes and sheathing. So taking this like a little step further even and reducing products that need to be integrated. Not that you still are going to need a vapor retarder on the interior or vapor barrier, but knowing that you can use your uh, plywood, not necessarily OSB, as an air seal just can offer more flexibility and sometimes does enable you to eliminate an extra trade involved in the wall or layer. And I'm going to tell you a little bit about a panel system that uses this strategy later. This has a little bit less of a learning curve associated with it. It's just more like obvious of how to install tape on a board, but you still really do need to think through the how the assemblies are meeting each other and how you can maintain that continuous air barrier. And then my favorite is integrating tapes and plaster. There are European products, tapes that are made to be embedded into plaster. They use a lot of plaster render finishes in Europe. And the plaster can act as a WRB or an air barrier or a vapor barrier. So it's a very multifunctional material or product to use, system to use. We've lost some traditional know-how in the US, but there are people who understand it well, and there's people doing new testing on new products, which is interesting. Again, I just want to highlight that it's reusable. Tapes and really any of these things are reusable, and I'm going to go back to the spray foam slide because it's worth acknowledging that when you use spray foam, you pretty much render every component of the building that it touches as unrepairable. It's very hard to do a renovation or reuse products or building parts that are covered in spray foam. All right, in cavity, getting into some like the nuts and bolts of products that exist. So in the US, we now have, and I'm going to include Canada, there are, I think, about 6 companies that are supplying straw panels. The tariffs are causing a little bit of a hiccup in this because one of them is coming from Europe and one of them is coming from Canada. But they are very cost effective. The most challenging part of implementing these that I've found is that the shipping from a coast, either a West Coast or an East Coast, to the Rocky Mountain region where I'm located, that's the expensive part. The rest of it is they're very cost competitive. And they are providing 2-hour rated walls with 0 toxins incorporated, especially when utilizing wood fiberboard insulation on the exterior and plaster. Some products are actually Passive House certified. One European company is, and a very high R value, very high performance option. The costs of the different panel types and products do vary quite a bit. And so while I said they're cost effective, like there's a lot of factors that play into that proximity, and then some are higher quality than others. One thing that's interesting to note is some of them have different structural strategies, which means that they may be a safer or a more complicated assembly to utilize, depending on your site, climate, etc. These are some different scale of projects that are constructed with straw panels. Actually, I'm sorry, the one on the right, the Argentild Architects building is not a panel project. It is a site-built straw bale infill project. It's a conventionally framed wall with straw bales, large ones, as infill. Just kind of to give you a sense that like what we knew in the 90s and early 2000s of straw bale construction, cob construction, like kind of a hippy dippy aesthetic, which can be really well refined and wonderful. We can also make very conventionally looking buildings nowadays. If you are in a warmer climate and and or just looking for like a little bump up to your insulation, you could incorporate a panel that is compressed and wrapped with paper. There's a company based in Texas that's providing panels that can be inserted easily into steel framing. And then the one in the middle is coming from Australia. It is available in the US. I think they may even have a manufacturer in the US now. I need to learn more. But this you can see is actually spanning across structural members. Any straw panel or straw assembly with very dense straws is very fire resistant, and these just continue that. These also offer that same fire resistance. And here's a couple of images of finished products using, or finished buildings using those products. If I dive into in-cavity insulation, we're looking at something that's really cost effective, like chopped straw is like the cheapest thing you could buy for insulation. Again, it needs to be dense packed for fire resistance because it does not have any chemicals added to it. Cardboard cellulose, I've heard, I haven't used it, but I've heard that it's like a cleaner install. Installers like it maybe a little better than cellulose, which I have used plenty, and it's not itchy, but it is messy. And wood, these are all kind of similar. They're fairly available from big box stores, obviously not chopped straw, but wood and cellulose are. They don't provide any, these ones obviously do not provide any shear capacity. And then on the fluffy side of chop straw, there's a company in Alberta, Canada that is providing, it's basically a double stud wall assembly with chop straw dense packed in it. Super cost effective and healthy, and it's a really smart assembly. I worked on a project in Utah, a small ADU, and we developed with a structural engineer this system using a Canadian wood fiberboard insulation that does provide shear capacity. We used it on the inside and the outside. We didn't need any plywood or OSB. So we were, like streamlining construction that way. and utilize locally available chop straw. And then the cardboard cellulose, there's a company based in New York, and wood is coming from Maine. All right, exterior insulation. These are wood chips compressed with some kind of binder. There's different processes. Fire resistant, very easy to install. It's kind of a one-to-one replacement almost for a rigid foam product. Some of them provide the shear structure, as I mentioned, and some of them you can apply plaster directly onto. This is easy to do in residential settings. I would say in a commercial setting, you might need to interface with your building department ahead of time. Um, Cork and hemp panels are really interesting as well. I love the aesthetic of cork. It really lends to like a very, very natural finish look. And it's, I think it can work as a weather resistant barrier. Some of the wood fibers can definitely, I'm not 100% sure with cork. And then a hemp fiberboard that's coming out of Idaho, which I mentioned earlier. It's a little bit like a rock wool product. It's got a little bit of squishiness to it. So I want to end and then open us up for questions on just asking ourselves, like, why haven't we used these more? And the reality is that with natural things that grow that you can't patent, there just historically has been less lack of funding compared to like chemical companies that have large corporations behind them. So we're behind in developing the technology and lack of testing. There is starting to be a lot more testing, which is great. And also just cultural barriers. With the Industrial Revolution and beyond, like expansion into the Western US, we culturally really embraced new products that sort of like promised a new horizon and lost some of our awareness of what these older materials, natural or traditional materials, offered. And so we're relearning those things now. And there's just so much potential there. And more, as I said, like more options for packaged solutions, which is a thing that we very much need in our industrial market today. And with that, I'd love to open it up. Well, I have one more slide. I just want to remind you again about the Natural Building Conference, and with that, open us up for questions and discussion.
Yeah, Lindsay, let's talk a little bit about um, climate resilience and resistance in regards to these natural materials. Um, one of the other aspects of residential green building and some of the various green programs, are starting to require the evaluation and knowledge of climate resistance, or what the calamities are coming. And then, of course, planning to mitigate, through the design and construction and renovation practices. And so thinking about where natural materials kind of come into play with that, just in general. So, of course, when I say climate resistance, I think of, a lot of the issues that are occurring right now. We've got fires raging all over the place. Are those burning down these buildings, these types of homes more? We've got sadly the tragedy in Texas with flooding, and where do natural materials come into play with like flood provisions? And then of course you've got an increase in tornadoes here, in severe weather, like in the Midwest here. Like in Michigan, I know we've had a massive increase in the number of tornadoes, hurricanes bearing down everywhere. And then of course earthquakes get kind of segmented into these climate resistance things. You have to think through, again, are natural materials more susceptible to, collapse during an earthquake event? So, So yeah, just the question here from our member Dennis was specific to sort of the severe weather outbreaks in the Midwest, but I want to enlarge it a little bit bigger just to in general like the interplay of natural insulations and materials and climate resilience. So
Yeah, thank you. There are a few aspects of that that I would like to address. I like to put things in boxes for my brain. So I'm gonna talk about just like higher performance as being one strategy,
right.
and then the just simply like the insulation of the materials and how they like actually, let me back up.
Mm,
When we're talking about disasters, there's a structural kind of a disaster or a
mm,
structural failure potential, and then there's
mm,
water and fire.
yeah.
On the high
Mm,
performance side of things, with heat waves or cold snaps or utilities failing, we know more and more that
mm,
buildings in these changing climates and
mm,
lack of utility grid um, sustainability, survivability is a factor now. Like our buildings are not able to provide the thermal protection that we need. So I would just advocate for higher
mm,
performance in general to prevent like loss of life. But then on the structural side of things, this feels um, like a little bit out of my wheelhouse because it's so much about like integration of structural members and fastening and how you're doing that fastening. Um, I will say that there are regions that have utilized natural
mm,
materials very successfully to mitigate natural disasters. I'm
mm,
thinking of Japan and earthquakes um, for many, many years. Sorry, thousands of years. And they've developed
mm, mm,
very good like
mm,
timber frame strategies. Um,
mm,
so I think that we have maybe more learning to do in the US about how to build our structures to withstand these disasters. I think that there's a easy argument to make for just building everything out of concrete.
mm,
Um, and we want to avoid that. We want to be able to use wood
mm,
as a structural material. Um, Maybe bamboo, maybe other things, I don't know, but wood is like the go-to low hanging fruit. So, yeah, I'm not the expert in it. I can say that, like straw, for instance, is a pretty ductile material and it has performed well in earthquake tests, but not well enough to avoid, like in my region where I am, I have very high seismic and high snow
mm,
loads. And with a straw bale assembly, infill post and beam frame, and plasters, it's not adequate. So I need
mm,
to incorporate some
mm,
sheathing or
mm,
some kind of cross bracing or some extra shear
mm,
support. And that's based on codes right now. That's um, thankfully we're not super prone to hurricanes
mm,
in this region. Wind is
mm,
wind is like terrifying to me. I don't know. I'm just overwhelmed by it. On the materials and like
mm,
fire and water, we're seeing very, very good performance of uh, these materials in resistance to fire, like better than conventional materials, unless you're talking about just concrete. There's
mm,
several flame tests that you could look up
mm,
online uh, that showcase how different
mm,
wall assemblies do with flames, and you will every time find that the straw is far superior to conventional materials. Um, in terms of water, I would never, I would never advocate that folks use like straw and clay in a rainforest. We don't have a lot of rainforests in the US, but we do have some humid climates, and straw can be used um, in pretty wet environments with the right detailing and the right approach. And and with vapor open finishes, like you can get away with a lot more than you can with, say, a plastic kind of a finish that's not vapor open. Um, there were floods in North Carolina and I guess that was mostly North Carolina last year, and people saw the hemp buildings perform very well. Like they had higher mold resistance to the water. Um, that's because of the lime primarily. Like lime is a very, very antimicrobial product, and utilizing it more for those benefits, I think we'll see more of that.
Yeah, and I want to kind of circle back to this moisture because obviously there's flooding, which is certainly just a huge influx of moisture, right? And that's one thing versus, of course, dealing with everyday just high humidity issues, right? A whole nother, those are kind of two different.
Yeah.
So I want to kind of, I'm glad you brought that up kind of at the end because I want to transition to those questions that are coming in. Um, but note somebody, made a good point about flooding, like, hey, maybe these natural materials are easier to clean up, less toxic when they are swept away, which I hope that's never happening, right? Let's make sure that never happens, but it does happen. So, but
Yeah.
real quick back to the wind, we have our member Climate. I don't think they're on today, or they can certainly chime in, but we did a session with them on climate adaptation, tech in the tube, and it's some strategies that we have available about how to make our homes more wind and seismic resistance. And so I believe that can be applied to natural materials as well when it's built with traditional framing. So you can check that out on our session. There's some potential strategies. Maybe we need to have that conversation later, bringing that kind of technology to the natural building material. But anyway, we have more questions. I want to switch into that moisture one, but before I do, a quick reminder that yes, this session is being recorded. You can wait a week to go to our YouTube channel, and it will be posted within a week, maybe faster, and catch it there. Or you can go there right now, click subscribe, ring the notification bell, and you'll get an instant update when it's available. If you want to rewatch this, share it with friends, post it on YouTube, help us get the word out. We love it when people, spread the knowledge around. For those of you here or for those of you watching this in the future on demand, not right now on the recording, you need to take that quiz with an 80% passing rate to receive your continuing ed certificates. For those of you here today, a survey will come up when you close out. Take that survey, especially if you're AIA, so we can report your CEUs. It'll be sent to you as well, so check your spam. But also in the next couple days, you'll get your certs from certs@gutenbergs.com as long as you've been here for the entire CEU hour. And you can check your spam for that. And again, take that survey because we want to hear your feedback, whether you need your certificate or not. And again, before we get into those questions, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, and our nearly 500 members. We're almost there. That's our goal for our 25th year anniversary is to reach 500 by the end of the year. So if you haven't subscribed, get on that. Otherwise, also a huge thanks to our top tier sponsors who are making products like Ream for water heating decarbonization, Build Equinox for intelligent air management, Tamarack for better ventilation, and Timber HP for wood natural materials. Huge thanks to them as well. So, yeah, I want to get to that moisture management questions that kind of came in about some of these, and that's always, the concern. So the specific question, at least this particular one, and then we'll look at some others where, how do you handle the moisture management in a straw bale wall? You were showing images of the straw walls earlier. Is it less critical if you're not trying to keep the interior face of the sheathing warm?
Let me make sure I heard that correctly. How do you manage moisture in a straw bale wall, and how do you make sure you keep the sheathing warm?
Yeah, well, so it's kind of they made a question and then made us really more of an inference on the question. So they said,
If
yeah,
they're
how
sheathing.
do you manage the moisture in the straw bale wall? And maybe that doesn't matter if you don't want to keep the interior face of the sheathing warm, is what we're thinking. So yeah.
That's a great question. I've addressed this, had to address this in multiple projects. Um, so some of the straw panel companies and also some that I've been part of construction with needed a actual shear panel, and like an OSB or ply. So moving the shear panel to the interior is one strategy for keeping it warm, and that's a pretty simple, like you don't have to add more layers to do that. That actually offers an opportunity to then use that as the air barrier. And then if you're using plaster on the exterior, the plaster operates as a vapor
Mm,
open WRB and protective finish
mm,
all at once. And it's a straw bales are a
mm,
very good plaster substrate. Um, so that's just one strategy. If you if you're having to use sheathing on the exterior like some of the panels do, then you need to make sure that you have a rain screen so that any moisture against that sheathing can dry out. You definitely want to use OSB instead of ply, which is more vapor open.
mm.
And it does complicate things a little bit, but there's ways around it. And then of course you can always apply exterior wood fiberboard insulation. And this is why I would advocate for actually um, running a moisture management like a woofy model, because
Mm,
in your specific climate, if it's dry like
mm,
mine, like I can really get away with very, very little exterior insulation. I don't have to always follow that rule of thumb.
mm.
It's more of a case by case basis.
Yeah, and I'm glad you brought that up. And obviously, Woofy or I think the Passive House planning package, one or the other, they're all giving you all this data, right? They're giving you the energy usage, they're giving you and I know the Passive House planning packages give you the embodied carbon, they're giving you the moisture risks. Very complex tools. I'd love everyone to use them. Of course, I wanted to shout out to Oak Ridge National Laboratory for creating the Building Science Advisor tool, which sounds like a lot of stuff in that name, but all it really is a moisture wall management risk assessment tool where you can plug in what you're doing in there. So we have a session on that too. You can check that out. Again, you should use Woofy or PHPP, but if you're like, I just got to do something real fast, I got a minute, that's what that tool does. And it's surprising to see in some of our climates just how awful we're building our homes today, and they're going to rot. Those walls are going to rot. So it's very troubling. And again, I'm not talking about natural homes. I'm talking about standard wall assemblies with fiberglass bats or cellulose insulation all on the inside. It's not looking good. So run that tool if you want some bad news. But it's all about informing people, to do the right thing. So I wanted to, you were talking about the panels, and this particular question was, can the structural insulated straw panel be used horizontal or angled as part of a roof assembly?
That's a great question. Yes, certain companies are providing those. There are some companies that are providing roof panels that are just filled with cellulose that can like pair with the straw panels. And then there are others that are providing straw filled roof panels. And
Right.
that's the, as you know, roof assemblies are can be a little trickier than wall
Yeah.
assemblies sometimes, or maybe it's more that we just focus on wall assemblies
Hmm.
more.
Yeah.
But you would treat that as a dense pack foam free roof assembly
Yeah.
unvented.
And speaking of these, panels, and I don't know if this is an issue just in general as we hopefully move to more of a panelization type kind of construction world, modularization, or if this is a specific question just on the natural material panels. But their question is, how do the electricians and plumbers deal with these types of panels?
Yeah, that's also, these are all great questions. You can, there's a number of ways to do it. um, I have done
Hmm.
plenty of integration of electrical and
Hmm.
mechanical systems into straw bale systems, and I've also done it in conventional buildings. And I know what it looks like in either case. And I personally don't actually think it's more difficult in one case or the other. I just think that if you haven't done it in the new instance, you might be a little intimidated by it. Um, it's very easy to use a grinder to just like route out a little chase in the straw. You know, you have to bury it. Maybe it's different in different jurisdictions, but I think it's approximately 2 inches beneath the finished material. And then come back and do a little patching with your plaster substrate for that. If you're using plaster, if you're using a panel that has quite a bit of framing in it, then you can just cut your chase into it, embed, you got to drill through the wood. There's plenty of wood in these panels to be able to fasten whatever finished material you want to. And you may want to use a moisture barrier, um, preferably a smart membrane. But some people simply choose to fur out a chase that just, it's more material, it's more cost, it's more embodied carbon. But if that gives you peace of mind of like applying your smart membrane and then furring out a chase, that's a pretty conventional streamlined solution. You could just use like 2x2s to fur that out.
Right. Now thinking about the air sealing, a couple of questions there. And one was really on the tapes and the membranes, less about the application or anything, but more about the recyclability. And I don't know if they meant the recyclability of those tapes and membranes during construction, where you have leftover, or if they're talking about thinking of the building in the future and what happens with them. But maybe you can, try to answer both. So,
Yeah, sure. I'd say I just want to, I guess, acknowledge that like recycling any building materials is a little bit challenging because we don't have like a market industry that supports that.
yeah.
And um, the tapes are not reusable. I should
Mhm.
have clarified that in the presentation. Like once it's stuck, it's stuck. Um,
Mhm.
it can be cut off though, and the membranes are, they have integrity. Um, for it's plastic, so
Mhm.
forever basically until it
Yeah.
breaks down via UV
Mhm.
or something.
Mhm.
Um, so they could, if the wall assembly was being disassembled, you could salvage that and reuse it.
Mhm.
And then um, you cannot send them to a recycling department, at least not where I live.
Mhm.
Um, I don't believe they are literally recyclable. I think they are reusable.
Mhm. Right. Yeah, that makes sense. And so also, you had mentioned flash and bat, some of the concerns with that, of course, being, the toxicity of foam, the health issues with that, the embodied carbon, and the cost, quite frankly, if I understand right.
Yeah.
It's an expensive product. So, what's your thought or experience with some of these, more sustainable sealants, we'll call them. So, two different kinds. One more labor intense one, being like water-based sealants, where you can kind of still do the flash and bat. It's really more just sealing up, you know, it's not necessarily the same thickness of a foam, but it's at least getting the air sealing down. And then it's just like water-based, usually has all like the Green Guard certifications on it. Have you seen that? What are your thoughts on that as a sort of middle ground approach to still air seal without foam?
I think it's a case by case thing. And like I've certainly used silicone and spray foam in small amounts for air
Mhm.
sealing.
Okay.
I'm not saying that they were like the best practice, but and I think the newer sealants
Hmm.
that are flexible over time are definitely going to be better than spray foam as a sealant, which I did 15 years ago and didn't know better. But that's going to turn brittle and not be a durable air seal.
Hmm.
So,
Hmm.
um, yeah, until we know more, like I do put faith in those certifications.
Hmm.
If we can avoid petrochemical products, great, but
Hmm.
you can't always. And so I think that finding a middle
Hmm.
ground is great.
Yeah. And what about some of these automatic air sealing products that are coming out where you can just basically hit the air leakage target you want through automation, right? You set up a blower
Right.
door and it just blows in the sealant and it,
Hmm.
covers everything. Are you seeing that as a thing that can work well with the natural or natural building or insulation or not?
Yeah, I kind of wish I had mentioned that because it is becoming more and more popular. I don't think it's in my market. There's no one providing that, but regionally, I have colleagues that use it and
No.
like it. Um, there's a, yeah, I think it's a pretty cost-effective solution and it can enable you with like a relatively small amount of petrochemical products to greatly improve the performance of the building, even late
Mm,
in the game. You know, air sealing is done
mm,
best when it's thought of early on and integrated throughout. And
mm,
if you're like, well, we didn't do that, so what do we do now? I think that's a great
mm.
option.
Yeah, sometimes referred to as the rescue product if you're not hitting your air leakage testing, but obviously you can use it for more than that.
Yeah.
Um,
Just make sure it's done right and that it's not um
oh yeah, absolutely.
yeah.
So there's a question about just your general opinion on sheep's wool, and then another question, so I'm going to add them together, and then another question asking, if you have an idea of sort of, and I don't know if they're talking about labor and material or just material here, but the material costs of, hemp or wool bat in a 2x4 framed wall versus, traditional fiberglass bat. So yeah, just, again, general thoughts on sheep's wool and then, how it compares cost wise. So,
Okay. Um, I don't hate fiberglass bats,
mm,
so I just want to say that. Um, they're 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 a lot better than many other things.
mm,
I personally kind of love wool, like it's cozy and sweet
mm,
and like I like the idea of it. It's not a US available product, and so I don't talk about it. It
mm,
is, I'm sorry, it is available, and we have great suppliers, even in the West. And it's more expensive, and it's not being
mm,
made in the US, at least not on a scale
mm,
that is like as easily
mm,
accessible as some other things. And I'm going to put hemp in this same category,
mm,
or a similar category. Like we do have
mm,
hemp grown in the US now, thankfully, and it's grown now in my backyard, like in Idaho, which is very cool. Um, the equipment that we use to process hemp in the US for building products, it's it's meant only to turn it into a building product. So in Europe, for instance, they are using hemp as a byproduct in building, but we don't have that opportunity here in the US. So while I like them from wool and hemp from simply like their properties, it's the supply chain that I think is lagging or lacking, and why I would advocate more to use cellulose, especially. Like cellulose is the cheapest thing that you can buy at a big box store. Um, and it performs very, very well. And it's it's just kind of a great no-brainer product. I
mm,
guess it's a little harder to install than bats. And that's why
mm,
the hemp bats are nice,
mm,
or wool bats or fiberglass bats.
mm,
Um, I think for me, I would kind of put, and this may not be fair to the
mm,
manufacturers, but personally, I kind of put fiberglass, hemp, and
mm.
wool into a little bit same category, and the fiberglass is going to be a lot less expensive than the three. Um, I don't know if that answered it correctly, but I can't answer that without including cellulose in that conversation.
No, and I'm really glad you did bring up cellulose because one of my region's, West Michigan's best kept secrets. And we just had them on last week. And so anyone can go and check that out. Is the fact that we actually do have a solid cellulose bat insulation that's do-it-yourself friendly,
Yeah.
made right here in West Michigan. So I'm very proud of that. And so we did an educational session though on just that kind of technology. It does exist out there. But you're right. I mean, it is hard when you're comparing the different materials. Cellulose certainly has grown in popularity to fiberglass. I mean, I think a lot of people are doing, they're not certain, they're not doing the bats that by any means. I'm not seeing that anywhere, but certainly the blow in, has, if anything, become more just as popular as fiberglass bats, at least in what I'm seeing anyway.
Yeah.
So, plus, it's just easier in the attics. You can just fill it right up, while the person's there. So, but no, Lindsay, I don't see any other questions right now. So since we do not, I wanted to give one more last shout out to the Natural Building Conference, the 2025 Rocky Mountain Natural Building Conference. And if you're watching this and the conference is over and you're like, now what? Because you're watching this on demand, don't worry, it'll be back again. I believe they do it every 2 years, I
Mhm.
think.
Yep.
Yep. So you'll have another chance in 27, another chance in, 2029. So you can still check that out no matter what. But yeah, other than that, Lindsay, where can people go to contact you or learn more about regenerative building solutions?
Thank you. Yeah. My website is regenerativebuildingsolutions.com. Actually, I better look that up. I think it's regenbuilding.com. It's regenbuilding.com,
Okay,
shortened for Regenerative Building Solutions.
right.
Um, and that is the easiest place. My email, we could post it in the chat if you want.
We'll send it out. Yeah.
Thanks. And yeah, I would be happy to talk to anybody and help them integrate some of these principles and materials into their projects.
Yeah, and also I know you're on LinkedIn. We're connected there. I know you share all sorts of great stuff and engage in conversation there, so I appreciate that too. And
Thank you.
encourage people to connect with you there as well, Lindsay. So, well, you know what, Lindsay, thank you so much for coming on, and thanks to the Natural Building Alliance for everything they do. Hopefully, I'll be in touch with them and getting more conversations about adopting this so we can have more sustainable housing. So, take care, everyone. Be well. We will see you again, same time, same place, next Wednesday. So, goodbye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.